Rematch is a set of plugins designed to match one view of video or film to another. In other words, to transfer the appearance of a clip to be consistent with another so that it looks as if it was shot with the same camera and used the same settings. In this tutorial, we will cover some of the basics within Rematch Stereo. The stereo plugin assumes that the input is an image pair where the two views are shot near each other and most often shot with a stereoscopic rig. I'm using After Effects for this tutorial, but you'll see that the controls are similar in your host application. Let's take a look at a few examples to see how it works. In this first example, we will discuss the basic philosophy and see how to use global color control and local refinement. If I apply Rematch Stereo and set the Match to our other view, the Rematch Stereo plugin will analyze the corresponding pixels on the other image and try to match the color. You can refer to the documentation to get the detailed explanations of each choice. Since we're not getting a perfect match, we can move on to the local modes to further refine our match. Rematch Stereo provides several options to further process each pixel individually by taking into account a local area around the pixel. First, the plugin internally calculates the best correspondence of each pixel in the target image to a pixel in the source image, which is automatic. But some of the pixels at the edges may not be mapped to corresponding pixels in the source image because of the difference in placement of the two cameras or lenses. In this case, the pixel-to-pixel correspondences are made using optical flow, which is commonly used for disparity mapping or motion estimation. If I set the local mode function to display the mismatch areas in red, you can see where optical flow warping is not working well according to our threshold for error tolerance, which is determined by the mismatch threshold percentage. We can adjust this mismatch map by increasing or decreasing the mismatch threshold percentage. You can see in the red area now is where the refinement needs to take over. Now I can leave it on normal. You can see we have a better overall match. In this next example, we have two views, and one view is missing the reflection and the sunlight that you see here on this view. We can do our basic global correction, but it isn't going to pick up that reflection. I will leave the local match mode to less detailed because I don't need to match any specific detail, and this option requires less render time. But you'll see in another example how the more detailed option works. I can set the local mode function to display the mismatch areas again. You can see that the default value of 7 doesn't work here because we don't want red in the areas where the reflection should be. So we adjust the mismatch threshold percentage value appropriately to include the areas where the mismatches are occurring, but not to include too many extraneous pixels where we see no problems due to the pixel tracking process. We can set this back to normal again, and you can see we have a much better match. Now let's look at another example. Here we have the two views on top of each other. Notice that one view is missing reflections and some of the detail that the other view has specifically in the monitors and on the desk. In this case, we can use Rematch Stereo to bring some of that extra detail to the other view. We go through the same process. First, we do a global match, and then if it needs more refinement, we move to the local tools. This time we get close by choosing Lab Histogram 2, and then we can move to the local tools for further refinement. I'm choosing the more detailed refinement mode, and you can see that brings us a close match to the other view. In this next example, we can see that we have a flare in one view and not the other. That's very distracting to the eye, so we want to remove it. First, I'm going to change this to side-by-side views of left and right eye, so we can compare the two views easier. The way we do this is simply by going to the Viewer tab and choosing New Comp Viewer. We can lock the view that we don't want changes to take place on. We don't really have a color matching issue, but need to replace part of a picture with a texture from the other artifact-free image. That's when the exclusion map becomes essential. We can start by going through the same steps. Select a global mode, and then a local match mode, in this case more detailed. We can make a garbage matte that fully covers all the pixels that we want to replace. Here, the flare moves. It's not like a piece of dirt on the lens. So the matte has to be animated to make sure that we fully cover all the pixels we want to replace. Since the flare happens only for a small section, we only need to make a matte for these frames and then can move the shape off screen for the rest of the sequence. And then we can check the exclusion matte box and select the layer which contains the garbage matte. Now you can see that the flare is gone. In this last example, we have two issues that need to be fixed. First, we have a problem with the color of the car in the two views, and then we also have a reflection on the hood of the car that is very different in each view as well. What's going on here is that the paint reflects the color differently based on the angle of the light reflection and the camera. It's a cool effect in reality, but it's something that can cause issues in viewing stereo pairs. Because the car is prominent in the scene, a global color correction to make the two cars match in color will create a difference in color of the objects of the background that aren't originally different in color. So we need to continue processing using one of the local match modes. We can start by setting the global mode so the car is closer in color. Note, the mean shift and gain plus offset modes are often adequate for simple exposure level differences. If the difference between the two images is not linear in behavior, then use one of the two histogram transfer modes. We can see, though, that the reflection is different in each eye still. If we want to match the reflections, we can animate a garbage matte that we can import from a roto program, or we can use the drawing tools in our host application to draw a simple shape to follow the reflection. And then we can select More Detailed to refine the mismatched areas and change Exclusion Matte to On. And then we select the matte that we just made or imported. The exclusion matte is shown in red. These are the pixels that we wish to replace with details from the source image. Now you can see that the color matches from view to view, and the reflection of the building is also matching from view to view. This is how you use rematch stereo to match one view of video or film to another.